Good day everyone, I am your teacher Anton. This is the continuation of the discussion of the part 1, which is the lesson polynomial functions and their graphs. Graphing polynomial function, the domain of polynomial function is the set of real numbers. The graphs of polynomial of degree 1 or 0 are lines, while the graph of polynomials of degree 2 are parabolas. Now the graphing monomials. Polynomial function in the form of p sub x equals ax raised to n. This is the simplest form of the equation. I prepared a graph. What if the function or the equation is x raised to 2. 2 is even numbers. The form of the graph is upward. How about the power of 10? So what is the difference of 2? When the exponent is smaller than the exponent of the second equation, from the graph form, smaller curve, while the greater degree or larger, the curve is wider than the smaller exponent. How about if the exponent is add x raised to 5th? The form is of the graph the smooth of the graph start from the lower to highest, then lower, then highest. That is the form of even numbers of the exponent. How about if the exponent is even numbers but greater than 5? What is the form? The greater even exponent number is wider than the even number is lower of the 11 is not the greater exponent, the wider is the graph form. If the even exponent, the form of the graph is not the same from the odd number of exponent. That is how interpret the graphing monomials. How about in the graph of general polynomial function? The graph is p sub x equals a x raised to n. Is changes its value. If the equation has the coefficient numbers, has positive or negative, what is the form of the graph? So let's observe. Now, here is the graph that I prepared. If the given equation is 1 over 8 x raised to 2 even numbers and has the coefficient 1 over 8, positive 1 over 8, what is the form of the graph? Since it is a positive coefficient of the term of the equation, the form of the graph is upward. 1. Another example. The equation is p sub x equals positive 4x squared. Since there is an coefficient 4 and positive coefficient 4 of the equation, the form of the graph is upward. How about if the coefficient is negative? What is the form of the graph? P sub x is equals negative 1 over 8 x raised to 2. The given is negative coefficient of the equation. It is negative. The form of the graph is downward. Another example, P sub x is equals negative x raised to 2. The equation again is negative coefficient. The form of the graph is downward. We can determine if the graph is downward if the coefficient of the first term or the highest degree is negative. All leading terms of the equation is negative, the form of the graph is downward. If it is positive, the form of the graph is upward. P sub x is equals ax raised to n plus constant key. Key is the units up if key is greater than 0. How about if key is down? If key is less than 0. If the constant is greater than 0, what is the form of the graph? If the constant key is less than 0, what is the form of the graph? The constant key is always located in the last term of the standard form. It is no variable. It is a number and it's located in a last term. Examples here is P sub x equal x raised to 2 minus 2. It's an even numbers of the exponent, and the form of the graph is upward, which is located from negative 2. So here's the negative 2. So upward, going to the negative 2, which is the constant key. Why is it upward? Because it is an even numbers. And it is positive. And even numbers is an upward. And the negative 2 is the constant. It's located in the lower part of y-axis, which is negative 2. That is the vertex of the graph. Now how about is odd numbers of exponents, which is 3, and a constant key is positive 2 is greater than 0. The form is since it is an odd numbers, the form of this graph is this one. And the positive 2 constant key is located in the y-axis, which is positive. The moving of the graph, if the constant key is positive, the move of the graph is from up which is located from the positive. If negative, the graph is going down. The vertex is located in the lower part of the y-axis, which is negative. Another example. P sub x is equals positive x raised to 3. 3 is odd numbers and it is positive and it's odd. So the form of the graph is this one. Why is it this one? It's because it's an odd numbers. And there is no constant key. So the constant key is automatically 0. Since 0 is located in the origin of the graph. So that's why the vertex is in. And the form of the graph is like this. Because of odd numbers of the exponent. How about if the equation is p sub x equals a, and there is a open parenthesis, which is x minus h, then close parenthesis, raised to the power of n. We can determine if the moving of the graph from the right, if h is greater than 0. If h is less than 0, the moving of the graph is located from the left side of the graph. We can determine the graph from up if constant key is greater. If constant key is less than 0, located from the down or the lower part. If the graph is on the right, the constant or the units h is greater than. If on the left, the h is less than 0. Example. There is an parenthesis. Inside the parenthesis is x minus 2 raised to 2. Since it is an even exponent of number, the form of the graph is upward. Up. And h is negative. So it becomes, the graph is located from the right side. From the right side here is this side. So the graph is located here from the right side. Since it is upwards, it is an even numbers, and is located from the right, it because the h is greater than 0. How about if the h is less than 0? H is less than 0 is located from the left side. Since it is in negative, x minus 2 raised to 3, which is odd numbers. So it is an odd numbers. The form of the graph is 1. It is located from the right. If you compute this one, h is greater than 0. Since it is an odd numbers of exponent, the form of the graph is like this. If even, the form is this one, which is upward. Now, continue another. The graph of p sub x equals a, open parenthesis, by x minus h, close parenthesis, raised to the power of n, plus k. It is a combination from the earlier that I discussed, which is from the parenthesis and there is a constant key. It is combination. Now, What is the form of the graph? If it is positive, constant, and if it is negative, constant. The form of the graph, like for example, here, the given is P sub x is equals open parenthesis, x minus 2, close parenthesis, raised to 2, minus 1. The constant key is negative. And even numbers, which is the exponent of 2. Form of the graph is upward. The vertex is located from the right upward, since it is an even numbers, and the constant negatives 1. The vertex is located from the plane area of the graph. How about if the combination, the vertex is located from the plane area of the graph? How about if the given is add, which is the exponent is raised to 3, and positive constant key? Since if add numbers, the form of the graph is this one, since it is an odd numbers, and the vertex is located from the space or in a plane of the graph, since it is a combination from the constant key and the h, and located from the right side. If there is no constant key, the origin automatically is on the 0 if there is no constant. Since the given is there is a constant key, so the vertex is located from the space of the graph. Add numbers, so the form of the graph is this one. If it is even numbers, the form is upward. If the constant or the leading terms is negative, downward. If it is positive, upward. The last is the turning. We notice that the graphs of polynomial function have turning points. Turning points are the points where the graph changes from increasing to decreasing or vice versa. Like this. Increasing, decreasing, increasing, decreasing, increasing. That is how the graph is formed. Or vice versa. Decreasing, increasing, decreasing, increasing, decreasing. That is the turning points of the graph. A polynomial function of degree n has at most open parenthesis n minus 1 close parenthesis. This is the turning points on its graph. If n is raised to 7, since the turning points is n minus 1, 7 minus 1, the turning points is 6. There is 6 turning points, which is lower, highest, 1, 2, 3, 4, 5, 6. There is 6 turning points. Even the exponent is 7, since the turning points is n minus 1. Example. The given equation is p sub x equals x raised to 4 minus 3x raised to 3 plus 2x plus 1. First you will do is to arrange from the highest degree to the lowest degree of the equation. Determine if the leading terms is positive, if the highest is 4 or 4 degree, and the last term is positive 1. And we can determine what is the turning points. What is the turning points? Since the highest degree is 4, since in minus 1, so 4 minus 1 equals 3. So the turning points is 3. Since it is a positive leading terms and positive constant, you can determine that the graph is upward. Why is it upward? It because it's an even numbers, which is 4, and the leading terms is positive. The graph is upward. And there is a turning points of 3. Count. Lower, highest, lower, 2, and 3. The turning points is 3, 1, 2, 3. Upward, it because of the even numbers and it is a positive leading terms, which is x raised to 4. How about this one? The highest degree or the exponent is odd numbers, which is 3. Since the degree is 3 and is an odd numbers, n minus 1, 3 minus 1 is equals to 2. There is a 2 turning points. There's 2 turning points in the graph, and the highest degree is odd numbers. So you can determine that the graph is starting from the form of vice versa. Highest, lower, 1, turn, another turn, 2. There is 2 turning points, 1 turning, another turn. There is 2 turning points from the use of this formula, and it is an odd number, so the form of the graph is like this, vice versa. Vice versa, if the highest degree is odd numbers, and if it's an even numbers, it is an upward graph of form. Now we are done to determine the different types of graph, on how to determine the moving of the graph, the smooth of the graph, and the turning of the graph, and the position of the graph.